So question 9 of the CSEC paper 2 deals with geometry and trigonometry and circle theorems. The handout that you are seeing on your screen, I am going to send it for you at the end of the class. Circle theorems are theorems that deals with circles, and you need to know the circles, and you need to know the properties of the circles, and you need to know the theorems as well. So the first theorem is the angle at which an arc of a circle subtends at the center is twice the angle at the circumference. So the first theorem is the angle at the center is twice the angle at the circumference. So that is the first theorem. You are not learning it as theorem 1, etc. All you need to know is the angle at the center is twice the size of the angle at the circumference. Whenever one side of the triangle is the diameter, the angle in the semicircle is a right angle. So that is theorem 2. So there are keywords that we look out for. The tangent of a circle is perpendicular to the radius. So when you hear the word tangent, right away, you're supposed to be thinking, well, okay, if the circle has a radius, the radius will meet this tangent at 90 degrees. So there are keywords that's supposed to trigger something in your brain for circle theorem. Tangent, radius, and 90 degree. We're going again. Angles on the same segment. So we're looking for something like this pattern here. Angles on the same segment, subtended by the same arc, are equal. That's a little bit wordy. All you can remember is angles on the same segment. So if I were to draw a line here, that is called a chord. So it means that the angle on the same segment is equal. What do I mean by a segment? A segment is a part of a circle, and the chord separates a major segment from a minor segment. So if we look at this here, this part is small. So we call that the minor segment. This other piece here, this is the bigger part, and that is called the major segment. So these two angles are on the major segment and they are equal. Cyclic quadrilateral. The word quadrilateral simply means it is a four-sided figure found inside of a circle, right? And the opposite angles are supplementary. So these are the opposite angles of a cyclic quadrilateral. This angle is opposite to this. So it means that the sum of these two angles is 180. Similarly, this angle is opposite this one. So these two angles add to give 180. The exterior angle of a cyclic quadrilateral is equal to the opposite interior. So this is the exterior, this is equal to the opposite interior. And the angle between a tangent and a chord at the point of contact is equal to the angle on the alternate segment. Yes, it is a bit wordy. So let us see if we can just break the tone by looking at a video here on circle theorems in 5 minutes. Or in 3 minutes. So let me share this with you all. Circle theorems in 3 minutes. You all hearing?
Hello and welcome.
Are you all hearing?
Yes, yes, yes.
The Teen Topics, where you'll be taught all you need to know about circle theorems. So a circle theorem is basically finding the angle within a circle, which has another shape inside it. These shapes are generally not drawn to scale, which makes it a little bit more difficult. But don't worry, in the next few minutes you will learn all you need to know about circle theorems. Okay, starting off, a chord is a line that lies anywhere below the diameter that goes from one side to the other of the circle. In this image, the perpendicular bisector of the chord passes through the centre of the circle. Number 2. Here we have a semicircle. Say we put another one on top and put a random triangle inside this half and name these angles A, B and C, then this angle B will become 90 degrees. But this is no fluke. Even if we have this triangle instead, or maybe even this one, they will always be 90 degrees. In fact, put any triangle here and it will still add up to, yep, 90 degrees.
So from the time the question tells you one side of the triangle is the diameter, automatically it is supposed to click. We're looking for 90 degrees.
Number 3. A tangent is a line that passes the outside edge of a circle. When this line is touched by the radius, that means the angle will be 90 degrees.
So from the time you spot a tangent, or the question says the line is a tangent to the circle, and you spot a radius starting from the center touching that line, automatically you are supposed to know we're looking for a 90-degree angle.
Number 4. A subtended angle is almost like our eyesight. When we look at an object, our vision is focused on that. Taking this tree and this man for instance, the subtended angle is 22 degrees. The subtended angle is basically the line, arc or object opposite to the inner triangle. Number 5. Angles in the same segment subtended by the same arc are equal. For example,
alright, let me watch that. So, right, watch this. Again, this is called the chord. This line here is called a chord. A chord splits the circle into two parts, a big piece and a small piece. The small piece is called the minor segment, the big piece is called the major segment. As long as we have two angles subtended by the same chord and the same segment, they are equal. So that is another theorem, right?
same arc are equal. For example, ABC is the same as ADC. Number 6. When you have an arrowhead shape inside a circle, the inner angle here is twice this angle at the circumference. Number 7. The diagram shows a Cyclic Quadrilateral, which is a four-sided shape with all of its corners touching the circumference. What is different about this is that the opposite angles both add up to 180 degrees, so A and C would add up to 180, and B and D, same thing.
So a cyclic quadrilateral is a fancy name for a four-sided figure found on outside a circle. So the opposite angles of a cyclic quadrilateral, and we know what opposite means. I am opposite to you right now. So those opposite angles add to give 180. Because we know a quadrilateral is just like a square, just like a rectangle. And the the sum of the angles in a square is 90 by 4, which is 360. So just like a cyclic quadrilateral, the sum of the angles inside that shape is 360 as well.
Number 8. Going back to the tangents, if you do not remember, go back to number 3, then the lengths of the two tangents would equal the same amount. To explain that with a visual guide, length AB is the same as AC. Number 9. The angle between the tangent and a chord is equal to the angle in the alternate segment. This is also known as an alternate segment theorem. Here was quite a confusing looking sum that you are likely to get in a maths exam. Have a look at this image and have a go. Can you do it? Pause the video and see what you can get.
All right, what I want to point out as well, this is a radius and this is a radius. So if two sides of a triangle, let me draw it. If two sides of a triangle are equal, this is a radius and this is a radius. What type of triangle is that? When we have two sides that are the same, it starts with I. What type of triangle is that?
Isosceles.
An isosceles. So it means that this angle here will be equal to this angle. So look out for the isosceles. Look out for the right angle triangle in the question. Look out for the tangent. Look out for the radius. Look out for the angle at the center. Look out for the angles on the same segment. So those are some theorems that you are supposed to be familiar with. So at the end of the class, I can send you some videos where the circle theorems are explained in a couple of minutes so you can get familiar with them. So we want to get straight into the questions, right? All right, let us read the question. The diagram below, not drawn to scale, shows a circle with center O. The points A, B, C, and M are on the circumference. The straight line CN is a tangent to the circle and the point at the point C. So we have that and it's perpendicular to BN. Determine, given a reason for your answer. We want A, B, C. Now, how do I call this line AB? How do I call that line AB? Does anybody know?
The diameter.
Diameter. So right away, AB is the diameter. So therefore, this triangle is found in a semicircle. And the theorem says the angle in a semicircle is a right angle. So this angle here is 90 degrees. The sum of angles in a triangle is 180. So work out this for me. Go ahead. All the angles should add to give 180. We have two angles, so we could find the missing angle. All right, the angle here is 32 degrees. Did you all get that?
Yes, miss.
Now the question says for 2 marks, state the reason for your answer. So this is 32 degrees and you can have 2 reasons. You could have the sum of angles in a triangle is 180, or you could have the angle in a semicircle is a right angle. So whichever answer you prefer, you will get the mark. All right, so right away, we were supposed to be able to get the angle at B. That wasn't too difficult at all. B is 32 degrees because we were able to identify the diameter. So that told us that the angle at C is 90 degrees. So let us continue. We want CMB. So we go in. CMB. So C to M to B. Now, how do we call a four-sided figure in a circle? How do we call a four-sided figure in a circle?
A cyclic quadrilateral.
A cyclic quadrilateral. And what do you know about the angles in a cyclic quadrilateral?
They are after 180.
Very good. So this is a cyclic quadrilateral. So that means M is opposite to 158. So work out the value of M. 180 minus 58. Work out that. Coming back in 1 minute. All right. What is the value at M? What is the value at M? (180) minus 58 is
122.
122. So this is 122. And the answer is the reason, because you get 1 mark for stating the answer and you get 1 mark for the reason. Opposite angles in a cyclic quadrilateral are supplementary, or they add to give 180. So you must write your answer and you must write the reason for the answer. All right? And it's worth 6 marks. NCM. NCM. So let me take out some of these lines here. We want NCM. So could we work out NCM? Can we work out this angle? If here is 122, can we work out this angle here? How much is the angles on a straight line? The sum of angles on a straight line is how much? Does anybody know? A straight line is how many degrees?
180.
180. So work out this part for me and then work out the angle here for me. And let's write down this because apparently we need to write it down. The sum of angles on a straight line is 180 degrees. So we have 90, we have 58, work out the angle at C. Who has the value for C?
degrees.
Yes. C is 32 degrees. And the reason is the sum of angles in a triangle is 180. Now this is a safe answer, right? So if you don't know what to put and it's a triangle, you may get away by putting that, right? I'm not saying to put that for all the things, and even if you put this for this answer, you'll get it wrong because this deals with the cyclic quadrilateral. So be mindful, sometimes if it is a triangle and you really don't have a clue what is the reason, you can't get away with the sum of angles is equal to 180 degrees. So yes, they are bringing circle theorems. They are bringing circle theorems for 6 marks, 3 marks for finding the missing angles, 3 marks for stating the reason. This will be coupled with solving triangles, so we'll go to that in a few minutes. So we want to do one other question. All right. The circle shown has a center O. A, B, and C line on the circumference. The straight line passes through A and B, right? The angle at B is 49, the angle at O is 37. Can you all spot the diameter? And if so, what is the diameter? The diameter is which length? Is it AB, BC, BD, OA? What is the diameter?
BD.
BD. So right away, this is the diameter. So therefore, we have the theorem that says the angle in a semicircle is a right angle. So work out for me y. All right, what is the value of y? Who can tell me the value of y?
41 degrees.
41 degrees. And what is the mathematical name for BC? It separates the circle into two parts, a major segment and a minor segment. BC is called, it starts with C and it is not the circumference. BC is?
Chord.
Yes. BC is the chord. Now, if you didn't know that before, learn it now, please. How do we call OA? It starts from the center and it touches one point on the circumference. OA is called? Good afternoon, Christian. OA is called?
Radius.
The radius. Tell me something, Charissa. Is OB a radius as well?
Yes, miss.
Right. Now, if two sides of the triangle is the same, well, this triangle has a special name because we have two sides that are equal. How do we call this triangle? A triangle is called? How do we call it? I'm not moving on until somebody give me the answer. How do we call the triangle? A scalene?
Isosceles.
An isosceles. Thank you. So if we didn't know that now, we know it now. So therefore, this angle here is 37 degrees. Work out the angle for me at X. What is the measure of angle X? Yes, Brittany, go ahead. What is the angle X?
106 degrees.
Yes. So X is 106. And the reason is OA and OB are radii. So OA, we could say OAB is an isosceles triangle. Y is 41 degrees, and the reason is the angle in a semicircle is a right angle. So the theorems are there for us to use, and the theorems are there for us to write in the question. So you'll score 1 mark for finding the measure of the angle, and you will score 1 mark for writing the reason. So you are getting circle theorems for 6 marks before 9 a.m. on Wednesday. Please familiarize yourself with all the theorems. The keywords, tangent, diameter, radius, right? Those are keywords that are supposed to trigger something in the circle theorems. Cyclic quadrilateral, all of those are keywords that will help you find the missing angles. They have identified solving triangles. So solving triangles has to do with the sine and cosine rule, right? So I believe that you are getting a question on bearings because they want you to solve triangles. So you can also get trigonometry as well. But solving triangles is mostly familiarized with question 9 of the CSEC paper 2. The diagram below, not drawn to scale, shows the relative positions of 3 reservoirs, B, F, and G, all on level ground. The distance BF is 32 kilometers, FG is 55 kilometers. The angle at F is 103, and the bearing is 42 degrees from B of F. Determine the bearing of B from F. So we always measure bearings from the north line. They want the bearing of B from F. So we are going to draw a north line from F. So I've given you a minute. Just quickly draw the diagram in your book. All right, do we have the diagram drawn in our book? Do you all have the diagram? So this is called the north line, right? We measure bearings from the north line. So we want the bearing where the line is at B. So this is the line here. We want this entire bearing. So we know that this is a straight line. Could somebody tell me how many degrees do we have on a straight line? Is it 200? Is it 360? Is it 90 degrees? How many degrees in a straight line?
What?
180.
I didn't hear. 180.
Yes.
180.
180.
Very good. So this here, this line and this line is parallel. And this is what we call Z-shaped angles. Z-shaped angles are called alternate angles. So if this angle is 42, this measure will be 42. So add for me 180 and 42, and that will give us the bearing of B from F. All right, 180 plus 42 is?
222.
222. So a couple things. We measure bearings from the north line. So if this angle here is a straight line, this is 180. So it means that we didn't find the whole angle. We want the angle of B from F. So we want this whole angle here. So this part is missing. Notice that this forms a Z. Z-shaped angles are alternate angles and they are equal. So this angle is alternate to this. So this measure here is 42 plus 180 degrees. That is the bearing of B from F. So this is 222 degrees. The next part, calculate the distance BG. So I am going to redraw this. So let us redraw it. We have B, we have G, we have F. Here is 103. We have here is 32. And this is 55. So redraw it in your book. And next it, right, we have two sides and the included angle. So this tells us that we are going to use the cosine rule. And the cosine rule is in the front cover of your mathematics booklet. For those of you all who have the booklet, you can check it. And if you can't remember the cosine rule, that's fine. It is there for you in the booklet. And the cosine rule is A squared is equal to B squared plus C squared minus 2BC cosine of angle A. So whenever we have two sides and the angle in between, we use the cosine rule. So this is the length that we want to find, BG. So our formula starts with BG. So here is A, this is B, and this is C. It is just a matter of plugging in the values into the equation and solving. So BG squared is equal to 32 squared plus 55 squared minus 2 by 32 by 55 by cosine of 103. You put in everything in the calculator and you're giving me an answer. Use the brackets for this part, please. The 2 open bracket, use the brackets for that. All right, who was an answer? 4,000 and who has an answer? 4,000. 4,840.83. Did you all get that?
Reference.
So therefore, BG is the square root of 4,840.83. Work it out. BG is
69.58.
yes, 69.58 kilometers. If you have 69.9, I will take that. Let us go through back this because you are getting solving triangles and you are expected to know how to use the cosine rule and the sine rule. What tells me that I have to use the cosine rule? In my question, I have 2 sides and I have the angle in the middle. So right away, that tells me I need to use the cosine rule. In the examination room, if you cannot remember the cosine rule, you want to go to the front cover of the formula booklet. The cosine rule listed there is a squared. What is A? A is the side that you want to find. So A is this side, then it is this first side squared plus the second side squared minus 2 by this cosine of A. You have to put everything in the calculator and you have to get this answer. To find the length, you find the square root. Calculate to the nearest degree the bearing of G from B. So where we see the word from is where we go and draw our note line. From B means that I am going to set up my note line from B. So I am going back to my diagram and I am going to set up my diagram, my angle from B. Now I can draw back my diagram here. So let me draw it here. So I have here this is my note line. This angle here was 42 degrees. This is point B. This is F. This is G. All right. I am going to set up my note line at B. So this is where I have my note line. I want the bearing, which is the angle of G from B. So I am going to start to measure from my note line and I am continuing until I reach the line that has G. Do you all see that? This is the measure I want because this is the point G. Do you all understand that? Yes, no?
Yeah, miss.
Yes, miss.
This is 103. So what do I want to find? I need to find this angle here. So I cannot use the cosine rule because I do not have the angle in the middle. That's why I want to try and find. So I will use the sine rule. And if we can't remember the sine rule, we can go to the front cover of the booklet, and the sine rule says A over sine A is equal to B over sine B. That is the sine rule. So we want to find, this is the information we're going to use. We don't need this. We have 2 lengths and 1 angle. So we can write that. We have 2 sides and 1 angle. We do not have the included angle. If we had the included angle, we could have used the cosine rule. So the sine rule is used for 2 sides and any angle, right? So A over sine A, well, we could call here A and we could call here B. So 69.58 divided by sine of 103, because this is opposite to this side, right? And then 55 is opposite to angle B. 55 over sine of angle B. All right, so somebody work out this part here for me. 69.58 divided by sine of 103. Work out that for me, please.
.41.
71.41 over 1 is equal to 55 over sine B. So we're going to cross multiply, right? So 71.41 sine B is equal to 55. So I am going to solve for B. So I have to divide both sides by 71.41. This is going to cancel. So B is equal to sine inverse of 55 over 71.41. Work it out. B is equal to
50.37.
50.37. So this angle here is 50.37. So the bearing is 42 degrees plus 50.37. Work it out. and give me the answer to 1 decimal place.
$92.4.
92.4. Who could confirm that?
Yes.
All right. So remember, you are getting solving triangles. You must be able to work out the triangles using the cosine and the sine rule. The information in the question will tell you which of the two rules you are going to use. So we're going to try one more, then we're going to take a short break and we're going into the next question, right? So the diagram below, not drawn to scale, shows a route of a ship cruising from Palm City to Caton and then to Rivertown. The bearing of Q from P is 133 degrees. So let us try and understand this. The bearing of from P, so P is where I set up my north line, and I am starting to measure until I find the line that is connecting Q. So that angle is 133, I have that. The angle PQR is 56. So we have that information. We want to find the angle at W. This straight line, how many degrees in a straight line? Does anybody know?
180.
180, thank you. So work out this angle for me here and watch this. This here forms a Z. So whatever measure this angle is, this one will be the same. So you can work out that and then work out W, because all three angles will give you 180. Try it, I'm coming back now. All right, let's hear what you have. Brittany, what answer do you have here for that little piece in yellow here? 180 minus 133, how much is that?
47.
Very good. 47. So therefore this angle is 47, and let's write down this. So draw my diagram here and write Z-shaped or alternate angles are equal. Then we have U-shaped. So let's write that as well. U-shaped or co-interior angles are equal. All right, so who could give me the measure of W? 180 minus 56 minus 47. W is how much?
77 degrees.
Very good. Did anybody else get 77? Did anybody get this answer to confirm it? Could you all check and see if it is 77?
Yeah, miss.
Thank you, Faith. The bearing of from. Underline the word from. From is where you go and you set up your north line. So you're setting up the north line at Q and you're measuring the angle until you reach the line containing the point P. So we're going. So I'm setting up my north line here. And I want the bearing, this big bearing here. This is R, I don't want that. I'm going straight up until I find P. How many degrees in a circle?
360.
360. So watch this. If it's 360 and this part here is 47, what is this piece here? The whole thing is 360.
318.
Yes. So the bearing is 360 minus 47, which is 313 degrees. Very good. All right.
Thank you, miss.
Good afternoon, Celicia. Thank you for joining us. We want the measure or the distance RP. So I'm going to draw back this diagram because it's looking a little bit confusing. So you draw the diagram too. We have 210. We have 290. We have P, Q, and R. We want to work out PR. This angle here is 56. All right. We have two sides and the included angle. Which rule are we going to use? Cosine or sine? We have two sides and the included angle. Which rule? Sine or cosine? Which rule do we use for two sides at the included angle?
Cosine.
Cosine. So let us label our diagram. Here we will call this A, B, C. I am writing the general formula for you, and I want you to work it out. I am writing a general formula and you give it a try. Let me know when you all have an answer.
Morning, miss.
Good morning. So we are looking at question 9 of the paper 2, and this is actually July 2021. Could someone tell me what page is it?
Page 161, Miss.
All right, let's turn to page 161 in the booklet. So let us read the first part of the question. Gives us some information to use, so we need to read that. In the diagram below, E, C, G, F are points on the circumference of the circle. We can see E, C, G, F. Now, if you notice, just by observation, this is a four-sided figure inside the circle. So that forms a cyclic quadrilateral. So right away, we know we have a cyclic quadrilateral. So we can write that. EG is the diameter. We want to underline that. So we are looking, EG is the diameter. So we are looking for the angle in a semicircle is 90 degrees. So we know that theorem. AEB is the tangent. What is the relationship with the tangent? What does the theorem with the tangent? Check in your cards that you made yesterday. What is the theorem with the tangent? Could anybody tell me what is the theorem with the tangent? Do you all have the cards you wrote yesterday? What is the theorem with the tangent?
A radius meets a tangent at a right angle.
Right, so you see these cards that I made you write yesterday? It is theorems that you need to know. So we're looking for a radius meets a tangent at 90 degrees. So look how much information I can get just by reading the first two lines of the question. I have not even looked at the diagram, but I know this is some information based on the theorems that I have learned before. So now I am going into the question and see what they ask me. Determine the value of each of the following angles. Show detailed working where necessary and give reasons to support your answer. When we have three letters together, the letter in the middle is the angle that we are looking for. So we are looking for ECD. So we are looking for this angle here, ECD. Do you notice that this line is parallel to this line here? Do you all see that?
Yes, miss.
What
Yes, miss.
shape is this?
A Z, miss.
Very good. What do you know about Z-shaped angles? How do we call Z-shaped angles? It starts with A.
Alternate angles, miss.
Alternate angles. And what do you know about alternate angles?
The next
Yeah.
side will be equal.
They are equal. So this angle is 68 degrees. So this is 68 degrees. And the reason is, because we need to write the reason, alternate angles are equal. So let's write. So you could take down the theorems I have on the side here. You can take down whatever working you need before we move on. So go ahead.
Finish, miss.
So here I scored 2 marks. We want C, E, G. So I'm going to take out my lines and I'm going to draw a line C, E, G. All right, so C, E, G. Now, how do we call O to E? What is that line called?
Radius.
A radius. What is the theorem with the radius? Look at here. What is the theorem with the radius? A tangent meets, a radius meets a tangent at 90 degrees. So if this is 90 degrees, can you find this missing part here?
Yes, miss.
Yes, miss.
Go ahead. What is the measure of the angle? How much is it?
22 degrees.
So it is 90 degrees minus
68.
68, which is 22. So 1 mark for that. The reason is OE is the radius. And a radius meets a tangent at 90 degrees or at a right angle. Is anyone still writing?
No, miss.
We go into C, G, F. C, G, F. But if you notice, this is part of a cyclic quadrilateral. Now, this is a U shape, and U-shaped angles are called co-interior angles. So, co-interior angles are U-shaped and they are supplementary, meaning that they add to 180. So if this is co-interior, work out this measure for me, please. 180 minus 106 is how much?
74.
Right? Write down this now. Angles on a straight line. Add to 180. So what is this angle here? 180 minus 68 minus 74. Somebody's mic is on and I'm hearing too much feedback in the background. So if you're not in a quiet room, please mute the mic. I'm hearing mommy talking or something like that. Go ahead, Christian, what's the value? What's the value here?
16. 16.
No, it's not 16. These three give us 180. So take 180 and subtract 68 and subtract 74.
Oh, sorry.
Brittany, how much is it?
38, miss.
38. Now we're going to use the cyclic quadrilateral theorem. The opposite angles in a cyclic quadrilateral are supplementary. So 180 minus 38 is how much?
142.
142. So 180 minus 38 is 142. Let's write. 180 minus 32 is 142. The reason is opposite angles in a cyclic quadrilateral are supplementary.
Excuse me, miss.
Go ahead.
Is 180 minus 38.
38, all right, thank you. 180 minus 38. So what I want to emphasize is that the first part of the question 9, gives a lot of information. And from there, you can write down the theorems to the side so you know exactly what you are looking at. You're looking for a cyclic quadrilateral theorem. You're looking for the radius meets the tangent at 90 degrees. So all of that should give you some hints as to what theorems you have to use to find the missing angles. All right, is anyone still writing?
No, miss.
So I want you to take a minute and complete the diagram if you haven't done so. In the diagram, I want to see 151. Be careful, this angle already is 69. I want to see 175. So fill the diagram with these two values. Go ahead. All right. Who would like to tell me where are we putting 175? Where are we putting 175?
H, miss.
HQ. Do you all have that?
Yes, miss.
No. I have 69 degrees. Where do I measure bearings? From which line? Bearings are measured from the north line. Do you all remember that from yesterday?
Yes,
Yes.
miss.
Right. So from the north line, the bearing from H, the bearing of R is 151. So it means this whole angle here is 151, not so?
Yes, miss.
No. If part of the angle is 69, what is the measure of this angle? This can be 51, 51. How much is it? Because we already have 69. So how much again to make 151?
82, miss.
Did you all get that?
Yes, miss.
Be careful that you do not put 151 for the whole angle, because if you put 151 for the whole angle, automatically it throws off the whole question, right? So bearings are measured from the north line, from the note line. And CXC tends to bring these types of questions whereby the students have to subtract the angle given to find the missing one. Is this a right angle triangle? Is this a right triangle?
No, miss.
So if it's not a right triangle, to find the missing sides, what do I use? What are the rules?
Cosine.
Or cosine rule or what?
Sine rule.
Right. No, I
Cosine.
use the cosine rule if I have two sides and the middle angle or the angle in between. Write it down. Write it down in your booklet. Sine rule is for two sides and any angle.
Only.
Write it down. Write down the flow diagram so we are clear as to which of the two rules we have to use. Now, do we have this side, we have this side, we want to find QR. Do we have the angle in between the two sides?
Yes, miss.
So with that information, Amrita, which of the two rules am I going to choose? Sine or cosine?
Cosine, miss.
Cosine. So here I am choosing the cosine rule. Why? Because I have two sides and the angle in between. So for simplicity's sake, I am going to redraw this diagram. And I suggest you draw it too, so you can see exactly what I mean. So draw the diagram. This is Q, R, this is H, here is 82, HQ is 175, and HR is 242. Do you see that I have two sides and the middle angle?
Yes,
Yes,
miss.
miss.
So we don't have to guess it. That tells us automatically we use the cosine rule. Now, this is the side opposite. So using our pencil, label the sides. This is A, B, and C. Let us write the cosine rule. If you forget the cosine rule, it's okay. This is how the booklet will look. You have to put your registration number, the center number, whatever. Look, they are giving it to you. They are giving you the cosine and the sine rule. So please, if you forget it, it is in the front cover of your booklet. The only thing they don't have a triangle. So Let me do it like how they have it in the booklet. So label here A, B, and C using the cosine rule. A squared is equal to the first side squared, that is what it means, plus the second side squared minus 2 by 2 by A by B, oh no, 2 by B by C. B by C multiplied by cosine A. So QR squared is equal to U-finity. Go ahead. All right, are you all finished? Are you all finished?
Yeah, miss.
So B is 175 squared, C 242 minus 2 by 175 by 242 multiplied by cosine 82. Now you have to put everything in the calculator and write your answer to about 3 decimal places. Seven 77401.038. Do you all have that?
Yes, miss.
So QR is the square root now of 77401.038. Give me the answer to 2 decimal places, please. Give me the answer for 2 decimal places.
Miss, you put 24 square instead of 242 square.
242, all right. Oh. What happened to this? All right. What is the square root of that answer?
$27.8.
No, 278.21 kilometers. Check it back.
Oh, yeah, miss. Sorry.
Now for 3 marks, you have to employ the sine or the cosine rule. For 3 marks, you must employ the sine or the cosine rule because it is a big application of a rule. That is why the marking is so much. But remember, if you did not put 82 degrees and you chose to put 151 as this angle, your working would be incorrect, right? So be very careful as to the measure of the angle. So let me leave that, and in case anybody wants to take it on, and we have part 3 to do. So far we scored 3 and 1 4. So this part of the question is worth 6 marks. So whatever they are asking us for the next part is worth 2 marks. Circle theorems is worth 12 marks in a CSEC paper. And the bearings or the angle of elevation or the depression. Calculate how far due south is ship R from the harbor H. How far due south is ship R from the harbor H? How far due south is the ship R from the harbor H? So we have to draw a line going in a southern direction. So draw a straight line from H this is a right angle. Let us call this X. So how far due south? We are looking for this length. What type of triangle is this?
Right angle, miss.
So if it is a right angle or a right triangle, we can use Pythagoras' theorem. Or we can use the trig ratios. Now, this is a straight line. So the sum of the angles on a straight line is 180. Find this angle for me in orange.
29 degrees.
29 degrees. Somebody could confirm that it is indeed 29.
Yes, miss.
So I am going to just, because my screen is so packed, I'm going to draw the triangle a little further down, right? So here I have a right triangle. This is H, I'm calling here XR. This is 242. Here is 29. So I want to find this side. So this is the opposite. This is called the hypotenuse because it is opposite the right angle. This side is the adjacent. So we have the adjacent side, the hypotenuse. Which trig ratio am I going to use? Look at the trig ratios. SOHCAHTOA. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. Tan opposite over adjacent. Which trig ratio am I going to use? Sine, cosine, or tan?
Cosine.
Very good. Cosine of 29 is hx on 242. So let's cross multiply. Hx is equal to 242 multiplied by cosine 29. I want the answer to 2 decimal places. To 2 decimal places, okay? Anybody with an answer?
Miss,
242. Go ahead.
miss, I get 211.7.
I want it to 2 decimal places. 211 point.
Miss
211.
65.
Well, the next number is 7. This is the number in the calculator. Write this number to 2 decimal places for me. 211.66 kilometers. This is my first decimal place. This is my second. This is my cutoff. This number is greater than 5, so I add 1 here. So let me leave it up in case anybody wishes to take it down. The rest of you find January 2021 in the booklet. All right, is it found? What page is it on? What page is January 2021 on? Could somebody give me the page number?
What to do?
Thank you. All right. So we have 9A to do and 9B. So I'm giving you 5 minutes. I'm giving you 5 minutes to see what you can do in question 9A. We only do a 9A for the meanwhile. Take 5 minutes, read the question, underline what you think is important. Underline what you think is important. And see what you can do in 5 minutes. Are you all ready? Are you all ready?
Yes.
So the diameter. What is the formula? What is the theorem that deals with the diameter? Tell me. If one side of a triangle is the diameter, the angle in a semicircle is 90 degrees. You all remember that?
Yes, miss.
Now, when we have parallel lines, what type of angles are formed? Parallel lines. What shape is this?
Z shape, miss.
A Z shape. How do we call these Z shape angles?
Alternate angles.
So we're looking for two things. We're looking for a semicircle, we're looking for a right angle, and we're looking for Z-shaped. So you see, just by reading those two lines, tells me what I am looking for in this question without even looking at the diagram. Explain why ABC is 90 degrees. Why is ABC 90 degrees? Which side is the diameter?
Miss AC.
Very good. So right away, I know for 90 degrees, that is a semicircle, and one length of the triangle must be the diameter. So that is what you're writing. AC is the diameter, and the angle in a semicircle is 90 degrees. That will award you your 1 mark. So take it out if you don't have it. Are we ready now?
Yes.
Determine the value of each of the following angles. Show detailed working when necessary and give a reason to support your answer. We are looking at BAC. So we want the angle here at A. BAC, we're looking for the angle at A. Now, what will give us the angle at A? This is 2P and this is 3P, not so?
Yes, miss.
So how much do those two angles add to give? What is the sum of those two angles? Because we already have 90. So how much would this angle and this angle add up to be?
Miss, you could subtract 90 from 180 and divide that by 5, and then the answer again multiplied by 2.
Very good. Did you all hear what she said? So this is already 90. So it means from 180, 90 is already taken. So this is the same P and this is 3P. So therefore 2P plus 3P will give us 90 degrees. So let's do that. 2P plus 3P is equal to 90 degrees. So 5P is equal to 90 degrees. How much is P? Well, we divide both sides by 5. P is equal to
18, miss.
but here we have 2P. So 2 by 18 is
36.
who could confirm the answer is 36?
Yes.
Yeah, miss. 36.
The reason is the sum of angles in a triangle is 180. That is the reason we used to find BAC. The sum of angles in a triangle is 180 degrees. Let's go. What shape is this here? What
Z,
shape is
miss.
that? A Z. So therefore, what is the measure of this angle here? What is the measure of that angle here?
36, miss.
36, because those are alternate angles. So Q is 36 degrees. And the reason is alternate angles are equal. So here we scored 5 marks. Instead of 6, it's 5. Oh, we are finished yet. We still have to find R. So R should be 1 mark. Yes, I am correct. R is 1 mark. Now, what is the measure of R? And why? What type of triangle is that? What type of triangle is this?
Isosceles.
Why? What tells you is isosceles, Amrita? OD is called what? What is the line OD called? Anybody? What is the line?
Radius.
The radius. What is the line OC called?
A radius.
So when we have a triangle bounded by 2 radii, I told you all that yesterday. When we have a triangle bounded by 2 radii, an isosceles triangle is formed. So the measure of R is 36 degrees because OCD is an isosceles triangle. Let's write that. OCD is an isosceles triangle. So you see how much information you could get just by reading the question, and the theorems are there for you to learn. All right. put in the information there. Any question for me? I want to see, I have already 185. I want to see 311. Put in 311, put in 5.4, put in 3.5. Go ahead. I want to see this length, I want to see this length, and I want to see this angle. Are you all finished?
Almost.
Are we ready? Did you all put in the values?
Yes, miss.
All right, let's see what you have. So QH is 5.4. So here this is 5.4 kilometers. HS is 3.5 kilometers. Do you have that?
Yes. Yes.
The measure of from the north line at H, the angle to Q is 311. So this whole angle here is 311. This part is 185. What is this angle?
311.
No. This whole angle here is 311. This part here is 185. How much is the missing part to make 311?
126.
126. Do not put 311. That is not 311 there. That part there is 126 because 126 plus 185 is 311. If you put 311, you wouldn't be able to get the question correct. So if you put that, change it. Remember that we have to subtract the other question that we just did. We had to subtract the angle. Are we ready?
Yes, miss.
All right. Calculate QS. So, which rule are we going to use to find QS? Do we have two sides?
Yes, miss.
Do we have the angle in the middle?
Yes, miss.
So which rule are we going to use? Two sides and the angle in the middle.
Cosine.
Cosine,
Very good.
miss.
Very good. Cosine. So, using the cosine rule, and let's write it. Let's get in the habit of writing it. So we remember, a squared is equal to b squared plus c squared minus 2 by b by c cosine a. So we could draw a simple sketch here rather than we going back and forth in the question. We'll draw a simple sketch of the diagram here. HQS, HQS, this is 126. HQ, I believe, is 5.4. HS is 3.5. This is the side opposite, so we're going to call this A. This is my A, this is my B, and this is C. Go ahead. Use the cosine rule and find the answer. Tell me when you have an answer, okay?
Yeah, miss.
You all have an answer?
Yes, miss.
All right. So QS squared is 5.4 plus 3.5 minus 2 by 5.4 by 3.5 multiplied by cosine of 126. When I put everything in the calculator, I get it's 5.4 squared plus 3.5 squared, 2 by 5.4 by 3.5 by cosine 126. 63.628. Did you all get that?
Yes, miss.
So QS is the square root of 63.628. QS is equal to 7.98 kilometers. Do you all have that?
Yes, miss.
Is there anybody in the class who didn't get that and would like me to go it over? All right, the last part now. Calculate the bearing of S from Q. So from Q is where I'm going to set up my note line. And I want the bearing from the note line all the way to S. The line is supposed to be straight. Now, I need to find this angle. I need to find this angle here. So, I have two sides, right? And so I have here as 7.98 kilometers. So I have two sides and the angle, so I can use the sine rule. I have 3.5 is opposite to the angle I want to find, and 126 is opposite to 7.98. So that is why they ask you to do that first. So using the sine rule, which is A over sine A, is equal to B over sine B. A is 7.98. What is the angle opposite A? What is the angle opposite A? What is the angle opposite A?
126.
So sine 126 is equal to 3.5 over that sine of Q. So we need to flip both sides to bring sine Q to the numerator. So sine of Q over 3.5 is sine 126 divided by 7.98. So we're going to cross multiply. Sine Q is 3.5 sine 126 over 7.98. Work out that for me. 3.5 sine 126 divided by 7.98. How much is it? Sine of Q is sine of Q is much is what? 3.5 sine 126 divided by 7.98.
Good morning, teacher.
Good morning. So we are going to the January 2020 paper. Let me see if I can pull it up here. What page is it on?
Page 71.
All right. Right, so let's turn in the booklet. This is January 2020, and we are on page 71. All right, is it all found? Did you all find
Yes,
it in the
ma'am.
booklet?
Yes, ma'am.
All right, so the question reads, the diagram below, not drawn to scale, shows the route of a ship cruising from Palm City, P, to Caton, Q, and then to Rivertown, R.
Excuse me,
Yes,
it's January 2020,
yes.
but I don't have that on my
So
I
you
don't
know,
have
tell
that.
me it's page 71.
Yeah, I have using a calculator or otherwise calculate the extract value of the following.
The question
For
itself is
9B?
on page 98.
Oh,
Amrita,
Yes, miss.
I am going to make you the co-host. When anybody is in the waiting room, you just admit them, right? Because I can't go back and forth with my iPad.
Yes, miss.
All right. Did you find it, Jonathan?
yes, miss.
All right. So we want to find the value of W. Now, yesterday we met some other angles when the transversal, when the lines are parallel, and these are called U-shaped angles. How do we call U-shaped angles? We know Z is alternate. What is U?
Miss, you sharing your screen?
Yeah, you're not seeing it?
No,
No.
miss.
Oh, just now. Sorry, I apologize. All right, are you all seeing it now?
Yes,
miss.
miss.
All right, how do we call U-shaped angles? Co-interior angles. Do you all remember that from yesterday?
Yeah, miss.
Are you all hearing?
Yeah, miss.
Yes, miss.
So write down Z-shaped are called alternate, and alternate angles are equal. Write that for me. Right? U-shaped are called co-interior. And they are supplementary. And the third one, the sum of angles on a straight line is 180. Take that down for me. I want you to get a chance, you can write them the little index cards. Amrita, somebody is in the waiting room, you let them in, please.
Yeah, miss.
Are you all ready? Is everyone ready?
Yeah, man.
Just a minute.
All right. This is called U-shaped angles. They are supplementary. So if this angle is 131, 133, what is the measure of this angle? If both angles add to 180, what is this angle? Who can tell me?
47 degrees.
Yes. 180 minus 133. This is 47. Now, this is a straight line. This is a straight line. So all the angles on a straight line is 180. Find W. How much is W?
Seventy
7
degrees, miss.
degrees.
77. Did somebody else confirm that?
Yeah,
Yeah,
man.
miss.
Yes,
So that
miss.
wasn't bad. For 1 mark, for 2 marks actually. So for 2 marks, you were supposed to find, you know why it is 2 marks? Because you have to find this 47 in order to find W. So you get 1 mark for working out this. You get 1 mark for W. That is why this is worth 2 marks. All right? Determine the bearing of from. Underline from Q in your booklet. Where we see the word from, we are going to set up the note line. So we're going to set up the north line from Q. This is my north line. What do we want? The bearing from Q of P. So we want this whole angle here. So this part here, we know it's 180 because that's a straight line. So find the sum of these two. W, we work out W as 77. So find those two.
Miss, we have to add.
Yes, you have to add.
That's 180.
180 plus,
180.
what you added? 180 plus 56 plus 77. That is the bearing.
Miss 313.
Who could confirm Jonathan's answer?
Yes, Miss.
Yeah, miss.
So we would have scored 2 marks. We would have scored 1 mark. So we have to get 3 marks again because this part is worth 6 marks. Now, what do we want to find? RP. This is not a right triangle. Do we have 2 sides?
Yes,
miss.
Miss.
Right? So do we have the angle in the middle?
Yes,
Yes,
miss.
Miss.
So which of the rules are we going to use? Sine or
Cosine.
cosine?
Cosine.
Cosine.
So let me draw back the triangle so it makes a little sense here. So you all draw the triangle too. This is 56. We have QPR. QPR. We want to find RP. QR is 290 and QP is 210. Using, and this is the application of the cosine rule, is always 3 marks. A squared is equal to B squared plus C squared minus 2B multiplied by C multiplied by cosine of A. Label the sides A, B, C. Substitute it into the formula. So you have RP squared is equal to, go ahead and do it.
Miss,
Yes.
6090.30.
All right. 6090.30. Who could confirm Jonathan's answer?
Yes,
Yeah,
miss.
miss.
Excuse me.
So, yes.
It's 620, then 9, and then 0.
All right. Now, how do we find the answer? What do we do?
Square root.
Right, find the square root now. So 2 decimal places, please.
245.13.
Very good. Make sure and for the units is kilometers. No, that was an easy 3 marks. You all don't find this question was easy for 6 marks?
Yes, miss.
Yeah, miss.
So if we learn this properly and we have question 7 down, and we do the same thing with the vectors and matrices, when it comes to the other question, we should be able to score as many marks, and that will give us a grade 1 in the exam. So we are getting there. So if anybody wishes to take it on, do so. The rest of you, find for me in your booklet, June 2019. So notice whenever we have to use the cosine rule, most of the times it is worth 3 marks.
Miss, what year we looking for?
June 2019. When it's found, let us know what page is it.
Miss May, June?
Yes, May, June.
I'm exactly on page 35. Paper 2, right?
Yeah, but what page is question 9 be on?
63, miss.
All right, thank you. Find in your booklet page 63 in the paper 2. Is it all found?
Yes, miss.
Yeah, miss.
The diagram below shows a quadrilateral PQRS where PQ and S are parallel. So we want to underline that. From the time we hear the word parallel, we should think about the Z-shaped angle. Parallel, the transversal cuts 2 parallel lines and alternate angles are formed. So from the time we read parallel, Z-shape supposed to come to our mind. SQ is 8. The angle at P is 90, all right? We have a right triangle. From the time we read that, we know we are not using the cosine or the sine. We are using either Pythagoras or the trig ratios, which is sine, cosine, and tangent. The angle at Q is 82, and the angle at, the angle at Q, they have the angle at Q is 82, But this is wrong. This is angle QSR is 82. So make that correction. This one here, the angle SQR is 30. So make that correction. That was wrong. The angle at S is 30 and the angle at Q is 82. So that was incorrect there. Now, this is the parallel lines. This is cut by the transversal. What shape is that?
A Z.
A Z. What type of angles are associated with Z-shape angle, with Z-shape?
Alternate.
So therefore, if this is 30 degrees, here would also be 30 degrees. Yes?
Yeah, miss.
All right. So let's redraw this triangle so it doesn't look so confusing. Here is a 30 degree. This is P, this is Q, this is S. Here is 8. We want to find PS. So the angle opposite PS, this is called the opposite side. We have the side opposite the right angle. This is called the hypotenuse. Which of the trig ratios am I going to use? Sine, cosine, or tangent? I want to find the opposite and I have the
Sine.
hypotenuse. Why?
Because you have hypotenuse and you have opposite.
So I'm going to use the sine ratio. So sine of 30 is equal to PS over 8. Let us cross multiply. PS is 8 multiplied by sine 30.
Miss 4.
Who could confirm that?
Yeah, miss.
Yes, ma'am.
Now, this is equal to 0.5. So write it. Sine 30 is equal to 0.5. So therefore, half of 8 is 4. So this was not too difficult. We were able to score 2 marks here. How? Because this is a right triangle. So right away, either Pythagoras theorem or the trig ratios are supposed to work. Is anyone still writing?
No,
We
miss.
want to find PQ. So let us draw the triangle again. We draw the triangle. PQS. 8 cm. 30 degrees. So I do not have the opposite but I have the adjacent and the hypotenuse. Sine, cosine, tangent. Which
Miss, you're using
ratio?
cosine.
So cosine of 30 is equal to PQ on 8. We can cross multiply. PQ is 8 cosine 30. Give me the answer to 2 decimal places, please.
Miss, 6.92.
2 decimal places.
6.93.
You have 6.928. To 2 decimal places, this is my cutoff. This number is greater than 5, so I add 1 here. So PQ is 6.93, and write the units, please. It is centimeters. Are we finished?
Yes, Miss.
We want to find the area of PQRS. Notice this is worth 3 marks. So this is the shape that we have. And yesterday from the multiple choice, we know this is called a trapezium. And the area of a trapezium is a half the sum of the parallel sides multiplied by the height. We have the height as 4 because this is PQSR. We have this as 6.93. That is what we worked out. But we do not have this. We do not have SR. So we need to find SR. So we're going to draw this triangle. I have Q, I have S, I have 30 degrees. Here I have 82 degrees. Here is R, here is 8. I want to find SR. It is not a right triangle. Not a right triangle. So I will use either the sine or the cosine. Now, do I have 2 sides?
No, Miss.
So therefore, if I do not have 2 sides, I will use the sine rule. So using the sine rule, and the sine rule says A over sine A is equal to B over sine B. So SR over sine of the angle, which is 82, is equal to, but we had to find this angle. Find this angle for me. Because this angle is opposite 8. We need that. Find that angle for me. Somebody find this angle if the sum of angles in a triangle is 180. Plus 68 over sine 68. So we can cross multiply. SR is 8 sine 82 over sine 68. Work it out. To 2 decimal places. What is the length of SR?
Miss 7.34.
No, it's 8 point something. Check it back.
8.5.
8.54 centimeters. Check it back, Salisha. So now, a half of the parallel sides, this is 8.54 centimeters. So a half 6.93 plus 8.54 multiplied by 4. .93 plus 8.54 multiplied by 0.5 multiplied by 4. And we will get 30 point something. Work it out.
Miss, the way how there you write it out the same way we went into the calculator, right?
You can add the numbers first, then multiply by 0.5, then multiply by 4.
Miss 1714.93.
No, that's incorrect. Add the whole number, add the
30.
numbers first. Go ahead.
30.94.
30.94 and area is in cm squared. Check it back, Nathaniel. So you could get a couple things. You could get trig ratios, you could get sine, cosine rule, or you could get angle of elevation and depression. So we're going to look at that in January 2019. So you all find January 2019 for me. Is anyone still writing?
Almost done. Yeah, Miss, I now get that.
All right, find for me January 2019. Tell me what page is it on?
Page 30.
30?
Yes, ma'am.
All right, thank you. Find page 30.
Introduction to angles of elevation
hear the
and
video?
depression. Every day, we look at different things around us.
Miss.
We look up to see things above us. We look down to see things below us. Angles are formed when we look up or down, and these angles are called angle of elevation and angle of depression. First, let's follow Dylan around the park to see the different angles of elevation and depression. Dylan looks up at the bird on the tree. When he looks up, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked up at the bird. There is an angle here. We say this is the angle of elevation. Elevate means to lift up. With this angle of elevation of the bird from Dylan, he takes a close shot of the bird. Next, Dylan now needs to locate the crocodile farm. He sees a signboard and he tilts his head. Again, there is an angle of elevation of the signboard from Dylan's eyes. Remember, Dylan was looking straight like this just now. Then he looked up at the signboard. There is an angle here. This is the angle of elevation. Dylan cannot see the words clearly. He walks nearer to the signboard. The angle of elevation of the signboard from Dylan increases as he walks nearer to the signboard. There it is. The crocodile farm is over there. He walks to the crocodile farm. At the farm, he sees the crocodile and he looks down at it. When he looks down, there is an angle formed. Let's find out where this angle is. Remember, Dylan was looking straight like this just now. Then he looked down at the crocodile. There is an angle here. This is the angle of depression. Depress means downwards. With this angle of depression of the crocodile from Dylan, he takes a picture of it. He walks a few steps on the platform and sees a mud skipper opening its mouth. That is a rare sight. He tilts his head down to capture the picture. Again, there is an angle of depression of the mud skipper from him. This angle is larger than the angle of depression of the crocodile from Dylan. Because the mud skipper is nearer to Dylan, he took a picture of it. Now that we have seen angles of elevation and depression like these, do you notice any similarities in them? Notice that both angles of elevation and depression have a horizontal line. Notice there is also a line touching the horizontal. It is this line that connects the object from the observer's eye. It's called the line of sight. Thus, an angle of elevation or an angle of depression is between a horizontal and the line of sight. The angles are also at the reference point, and the word from is important to determine the reference point. Adding on, is there any relationship between these two angles? Let's continue following Dylan to find out. Dylan sees a squirrel on the tree. There is an angle of elevation of the squirrel from him here. Let's draw the horizontal and line of sight. Can you identify it? It is here. Interestingly, the squirrel looks back at Dylan. There is an angle of depression of Dylan from the squirrel. Let's draw the horizontal and line of sight. Can you see it? It is here. Since both horizontals are parallel and are cut by the same line, these two angles are equal. Dylan takes a picture of the squirrel and walks on. All in all, when we look up, an angle of elevation of the object from us is formed. Specifically, angle of elevation is the angle between the horizontal and line of sight. When we look down, an angle of depression of the object from us is formed. And an angle of depression is the angle between the horizontal and the line of sight too.
All right. Do you all see the difference between the angle of elevation and the angle of depression?
Yes, miss.
So if you are seated in your chair, wherever you are seated in your home, and you look straight ahead to the screen of your device, that is called the line of sight. So if this is me here, and I am watching straight ahead, this is called my line of sight. If I am going to watch the ceiling, or I'm going to watch a spider or something on the ceiling, and I look upward, my line of sight changes. And this angle, because I am looking up, I am happy, I am elevated. This is called the angle of elevation. When we are sad, we tend to tilt our head downward, and we tend to be depressed. So that angle is called the angle of depression. Do you all see the difference between the two?
Yes.
All right. Let's read the question. A person at the top of lighthouse TB shows two ships, S1 and S2, approaching the coast as illustrated on the diagram. The angles of depression. So if the person is looking downward, the person is standing here, and the person is looking down towards the two ships. So this is the angle of depression. 12 degrees and 20 degrees, respectfully. So the first angle is 12 degrees, and the bigger angle is 20. Do you all see that a Z shape is formed here?
Yes, miss.
So therefore, what is the measure of this angle and what is the measure of this angle? Take it down and put in the figures. I also want you to put in 110 meters on your diagram. Do you all have it? Did you all put the values?
Yeah, miss.
So here is 12 and here is 20. Do you all have that?
Yes, miss.
Also, the ships are 110 meters apart. Did you all put in that as well? The first part for 3 marks, right? For 3 marks, so we know we have to use either the cosine or the sine rule because the trig ratios don't ever be 3 marks. So let us draw, we want to find TS2. So let us draw a diagram. This is S1, this is S2, this is 110 meters, this is T. If this whole angle is 20 and that part is 12, what is this piece? The whole angle is 12. The part in green is 12 here. The whole angle is 20. What is the part in yellow?
8.
8. Do you all agree that this angle here is 8?
Yes, miss.
Now, let us, so we want to find TS2. So we must find this angle here. This angle is TS2. Oh, so we need to find this angle. Here is 12. Find the missing angle at S1. 180 minus 12 minus 8.
60.
60? Is it 60?
160.
160. Do you all agree?
Yes, ma'am.
Yes, miss.
So we want to find TS2. Now, we have 2 angles on one side. We have 2 angles, but only one side. So this tells us that we have to use the sine rule. So using, we're not concerned with this, so I'm taking this out. Using the sine rule. So what is the side opposite 8? What is the length of the side opposite 8 degrees?
110.
So
110.
over sine 8 is equal to TS2 over sine 160. So let us cross multiply. So TS2 is equal to 110 multiplied by sine of 160 divided by sine 8. TS2 is equal to and they want the answer to the nearest meter. They want the answer to the nearest meter. Give me
Miss,
the answer for 2. Go ahead.
4.702.
No. 110 multiplied by sine 160 divided by sine of 8.
270, miss.
Yes, 270 meters. Check it back, Nathaniel. Could anybody else confirm Josiah's answer?
Yes, miss.
So
Yes,
remember,
miss.
for 3 marks, when it's worth 3 marks, we have to either use the sine or the cosine. If we given 2 angles on one side, that means we use the sine rule. If we are given 2 sides and the middle angle, we use the cosine, right? The height of TB. So let's draw this. Just draw this with TB. TB S1. TB S1. Here is 20. This one. This is DC. Here is 12. 20. This is 20. This here is 270. We want to find this side here. All right, which trig ratio are we going to use? Sine, cosine, or tan? We want to find the opposite side.
Sine.
So sine of 20 is equal to TB over 270 meters. So if you cross multiply, TB is 270 multiplied by sine 20. TB is equal to oh, no, I used the wrong angle.
32.3.
No, I used the wrong angle here. I'm supposed to use 12. So let us use 12 here. And this is BS2. BS2. So this will be sine 12. So just make that correction. Here's 12. So it's 270 multiplied by sine 12. And we want the answer to 1 decimal place, or to the nearest meter.
56.1.
Yes, 56.1 meters. Did you all get that?
Yes, ma'am.
Yeah, miss.
So watch this. Here we have a right triangle. We use any 12 here, and we get in here as 56.1. This one here, whenever you see triangles like this, of this shape, that should tell us that we are using the sine rule. So whenever you see this kind of scalene triangle, look, that should tell you you are using the sine rule. This is a right triangle, so we use any trigonometric ratios. When we look above, the angle is called the angle of elevation. When we look downward, the angle is called the angle of depression. So we have completed question 7 and question 9 of the CSEC past paper. It is 2 minutes past 11. We are taking a break until 1/4 When we come back. All right, so it is 3 minutes past 11. You will come back at 10. All right, find for me in your booklet, January 2020. What page is it? The paper 1, Jan 2020.
57, miss.
Page 57. Did we do that one yesterday?
Yes, miss.
We completed that one?
Oh no, miss, you can wait for homework.
Miss paper 1?
$40. Are you all hearing me?
Yes,
miss.
Check in your booklet, January 2020 on page 57. Did we complete that yesterday? A volume, side by side by side. The volume 6 by 6 by 6. The answer is 216 centimeter cube. The answer is D as in dog. If it took a speedboat 9 hours to travel 1,080 kilometers, speed is distance divided by time. 1,080 divided by 9, it is 120 kilometers per hour. The answer is C. Do you all have that?
Yes, ma'am.
250 millimeters expressed in meters. 1 millimeter is 1/1,000 meters. So 2,500 divided by 1,000, we will cross our zeros, and 25 divided by 10, this is 2.5 meters. The answer, B as in boy. An aircraft leaves 1600 hours and arrives at 1930. So the time 16 to 17 is 1 hour. 17 to 18 is 1 hour. 18 to 19 is 1 hour. And 19 to 1930 is half hour. So the time is 3.5 hours. The speed is 550 kilometers per hour. Speed is distance over time. So if we cross multiply, distance is speed multiplied by time. So the distance is 550 multiplied by 3.5. 3 2s are 6 and 1 7. So 550 multiplied by 7 over 2. 550 divided by 2 is 275. And 275 by 7 is 1925 meters. The answer, D as in dog. We did this one as well yesterday with the vegetable garden plot. The length is 15, the width is 12. Part is used for vegetables, which is 80 meters squared. So the area, 15 by 12, 180. So if 80 is used for vegetables, 180 minus 80, which is 100, will be used for fruits. Take down what you need on the screen. The distance around the lake, we have to change 8 kilometers to meters by multiplying by 1,000. We have to change meters to centi by multiplying by 100. So to go from kilo to centimeters, we multiply by 100,000. So 2 cm is equivalent to 800,000 centimeters. So 1 is equivalent to 400,000. The answer, D as in dog. Is anyone still writing?
No, Miss.
This one we met already yesterday. The volume is cross-sectional area by height. The volume is 320. The area by height. So we want to make the area the subject. We divide both sides by 5. 5 to go into 320, 64 times. So area is 64. Told us that it is a square. So the length of one side is the square root of